How to choose the right classic car engine oil. A freshly restored classic car sat gleaming beneath the lights of a weekend car show. Its chrome sparkled, its paint reflected the afternoon sun like a mirror, and the proud owner could hardly contain his excitement as admirers gathered around to admire years of painstaking work. Yet only a few months later, a troubling sound emerged from deep within the engine. What began as a faint ticking noise gradually developed into a serious mechanical problem. The owner was stunned. The engine had been rebuilt by professionals. The maintenance schedule had been followed carefully. Everything seemed perfect. The culprit turned out to be something few enthusiasts ever considered dangerous: the wrong engine oil. Suddenly, a simple question became impossible to ignore. How could something as ordinary as motor oil determine whether a valuable classic engine thrives for decades or suffers catastrophic damage? To understand the answer, we must travel back to the earliest years of the automobile. During the late 19th century and the opening years of the 20th century, automotive technology was still in its infancy. Engines were primitive by modern standards, manufacturing tolerances varied widely, and lubrication technology struggled to keep pace with rapid mechanical innovation. Early motorists frequently dealt with oil leaks, excessive wear, and frequent maintenance intervals that would seem astonishing today. By the 1920s, automobiles were becoming increasingly reliable, but engine oil remained relatively simple. Most lubricants were refined directly from crude oil with minimal additive packages. Drivers often changed oil frequently because contamination from combustion byproducts quickly degraded lubricant quality. Yet even these basic oils represented a significant improvement over the products available only a decade earlier. As the 1930s arrived, automotive engineers continued refining engine designs. Higher compression ratios, improved metallurgy, and better manufacturing practices allowed engines to operate more efficiently. Oil manufacturers responded by developing lubricants capable of handling greater temperatures and longer service intervals. Throughout this period, the relationship between engine design and lubrication became increasingly important. Every mechanical improvement created new demands for oil performance. The outbreak of World War II in 1939 accelerated technological progress dramatically. Military vehicles operated under harsh conditions across multiple continents, forcing engineers to develop more advanced lubricants. By the time peace returned in 1945, oil technology had advanced significantly. These wartime innovations soon found their way into civilian automobiles, creating excitement among manufacturers eager to build more powerful and reliable engines. The 1950s introduced an era of extraordinary automotive growth. Across America, Europe, and other developing markets, consumers embraced larger vehicles and increasingly powerful engines. V8 powerplants became symbols of prosperity and freedom. As horsepower climbed, lubrication requirements grew more demanding. Oil manufacturers introduced new additive technologies designed to reduce wear, combat corrosion, and improve engine cleanliness. The science of lubrication was becoming far more sophisticated than many drivers realized. Then came the performance revolution of the 1960s. This decade witnessed the rise of muscle cars, high-performance sports cars, and increasingly aggressive engine designs. Manufacturers pushed engineering boundaries in pursuit of speed and excitement. Legendary engines from Ford, Chevrolet, Chrysler, Pontiac, Jaguar, MG, Mercedes-Benz, and numerous other manufacturers emerged during this remarkable era. Many of these engines relied on flat tappet camshaft designs that created extremely high contact pressures between moving components. To protect these heavily loaded surfaces, oil manufacturers incorporated an additive known as zinc dialkyl dithiophosphate, commonly called ZDDP. This remarkable compound provided a protective anti-wear barrier that reduced metal-to-metal contact under extreme conditions. For performance engines equipped with flat tappet camshafts, ZDDP became one of the most important ingredients in motor oil. Throughout the late 1960s and into the 1970s, engine technology continued evolving. Manufacturers sought greater performance while simultaneously addressing emissions regulations and fuel economy concerns. Oil formulations adapted accordingly. Additive packages became more complex. Multi-viscosity oils gained popularity. Lubricants could now perform effectively across a wider range of temperatures than ever before. At the same time, viscosity ratings became increasingly important. Numbers such as 10W30, 10W40, and 20W50 began appearing on oil containers. These designations helped drivers understand how oils behave during cold starts and at operating temperatures. Engineers carefully matched oil viscosity to engine design, bearing clearances, and operating conditions. Choosing the proper oil was becoming a technical decision rather than a simple maintenance task. Many modern enthusiasts assume that today's motor oils must automatically be superior for every engine ever built. The reality is far more complex. Modern oils are specifically engineered for contemporary engines equipped with roller camshafts, advanced emission systems, catalytic converters, and extremely tight manufacturing tolerances. To protect modern emissions equipment, many oil formulations contain lower levels of ZDDP than oils commonly used during the muscle car era. This creates a surprising challenge for classic car owners. An oil that performs brilliantly in a new vehicle may not provide ideal protection for an older engine designed around entirely different lubrication chemistry. The very advances that benefit modern automobiles can sometimes create concerns for vintage power plants. As collectors invest enormous sums preserving automotive history, awareness of these differences has grown dramatically. Restorers, mechanics, engine builders, and enthusiasts increasingly study lubrication science with the same passion once reserved for horsepower ratings and quarter-mile times. They understand that selecting engine oil involves much more than reading a label or choosing a familiar brand. The deeper they investigate, the more fascinating and complicated the subject becomes. Viscosity, additive chemistry, climate conditions, engine wear, synthetic formulation, break-in procedures, and manufacturer specifications all play critical roles. What initially appears to be a simple purchase gradually reveals itself as one of the most important decisions a classic car owner can make. And this realization is only the beginning of understanding how to truly choose the right engine oil for a valuable classic automobile. Once a classic car owner realizes that engine oil is far more than a routine maintenance item, an entirely new world of engineering, chemistry, and mechanical science begins to unfold. What appears to be a simple row of bottles on a store shelf actually represents decades of research and countless variables that can influence the longevity of a valuable engine. For enthusiasts who have invested years restoring a cherished automobile, understanding these details can mean the difference between preserving history and unintentionally accelerating wear. The journey begins with viscosity, one of the most important characteristics of any motor oil. Nearly every oil container displays numbers such as 10W30, 15W40, or 20W50. To many owners, these figures seem confusing, yet they provide essential information about how the oil behaves under different temperatures. The first number, followed by the letter W for winter, indicates how easily the oil flows during cold starts. The second number reflects the oil's viscosity at normal operating temperature. Imagine a cold morning in January. The engine has been sitting overnight, and every moving component depends on oil reaching critical surfaces as quickly as possible. If the oil is too thick, circulation may be delayed, increasing wear during startup. If it is too thin at operating temperature, it may fail to maintain a protective film between bearings, camshafts, and other heavily loaded parts. Finding the correct balance becomes essential. Climate plays a significant role in this decision. A classic car operating in the cool climates of Northern Europe faces different lubrication challenges than a muscle car cruising through the deserts of Arizona. During the 1960s and 1970s, manufacturers often provided different viscosity recommendations depending on seasonal temperatures. These guidelines remain valuable today because the laws of physics affecting lubrication have not changed. Engine condition introduces another layer of complexity. A freshly rebuilt engine with factory-correct bearing clearances often benefits from different oil characteristics than a high-mileage survivor that has accumulated decades of wear. As engines age, internal clearances can gradually increase. Some owners find that slightly heavier oil grades help maintain oil pressure and reduce consumption in worn engines. Yet choosing excessively thick oil can create its own problems, especially during cold starts. The discussion becomes even more fascinating when camshaft design enters the picture. Many classic American V8 engines from the 1950s, 1960s, and 1970s relied on flat tappet camshafts. These systems generate extremely high contact pressures between the cam lobes and lifters. This is where zinc-based additives such as ZDDP become critically important. Without adequate anti-wear protection, accelerated camshaft wear can occur, particularly during break-in periods or under high-performance conditions. Enthusiasts restoring legendary engines such as Chevrolet's small block V8, Ford's Windsor series, Chrysler's big block engines, or Pontiac's famous V8 powerplants frequently pay close attention to ZDDP levels. Engine builders often recommend oils specifically formulated for classic vehicles or high-performance applications to provide the necessary protection these designs require. Hydraulic lifters introduce additional considerations. These components depend on proper oil pressure and cleanliness to function correctly. Selecting an oil that matches the engine's design helps ensure smooth operation while minimizing valve train noise and wear. Every mechanical system within the engine interacts with the lubricant in ways many drivers never realize. Then comes one of the most debated subjects in the classic car world: synthetic oil. When synthetic lubricants became widely available during the late 20th century, they represented a major technological advancement. These oils offered superior thermal stability, oxidation resistance, and cold weather performance compared with many conventional oils. For modern vehicles, their advantages are often undeniable. Yet classic car enthusiasts remain divided. Some admire the protection and durability synthetic oils provide. Others prefer conventional formulations that more closely resemble the lubricants available when their vehicles were originally built. In reality, the best choice often depends on the specific engine, its condition, and how the vehicle is used. Semi-synthetic oils offer a middle ground. By blending conventional and synthetic base stocks, they provide some of the advantages of modern lubrication technology while maintaining characteristics that may suit older engines. Many owners find this approach appealing, especially when balancing performance, cost, and historical authenticity. Examples from around the automotive world illustrate how diverse these decisions can become. A 1967 Chevrolet Camaro SS, equipped with a flat tappet V8, may benefit from a high-zinc 10W30 or 15W40 formulation. A British sports car such as an MGB or Triumph TR6 often relies on oils specifically suited to its unique engine and operating conditions. European classics from manufacturers like Mercedes-Benz, BMW, and Jaguar frequently have factory recommendations that differ substantially from their American counterparts. Even classic Japanese vehicles from the 1960s and 1970s can possess lubrication requirements that reflect their own engineering philosophies. What becomes increasingly apparent is that there is rarely a universal answer. The ideal oil for one classic car may be entirely inappropriate for another. Engine design, climate, mileage, intended use, maintenance history, and manufacturer specifications all contribute to the final decision. This growing understanding often transforms the way enthusiasts view maintenance. What once seemed like a routine oil change evolves into an informed process supported by research, experience, and mechanical knowledge. Owners begin appreciating the remarkable science that allows a thin film of lubricant to protect thousands of moving parts under intense heat and pressure. The more one learns about lubrication, the greater the admiration for the engineers and chemists who developed these technologies over the decades. Yet choosing the right oil is only part of the equation. Proper maintenance practices, storage procedures, filter selection, break-in oils, and long-term care ultimately determine whether a classic engine enjoys a healthy future or faces preventable problems. And those practical lessons reveal the final chapter of this fascinating story. By the time a classic car owner understands viscosity ratings, additive packages, and the differences between conventional and synthetic lubricants, a deeper realization often emerges. Choosing the correct engine oil is only the beginning. The true protection of a vintage engine depends on a complete maintenance strategy that combines knowledge, consistency, and attention to detail. This is where decades of automotive history intersect with the practical realities of ownership. Many enthusiasts assume that because they drive their classic cars only occasionally, oil changes can be postponed indefinitely. Yet time can be just as damaging as mileage. Engine oil gradually absorbs moisture, fuel contamination, combustion byproducts, and microscopic metal particles. Even a vehicle that spends most of its life parked in a garage remains vulnerable to chemical degradation occurring within the lubricant itself. This reality becomes especially important for collector vehicles. A beautifully restored muscle car may travel only a few hundred miles each year, but its oil still ages. Professional restorers and experienced mechanics often recommend changing the oil at least annually, even if mileage remains low. The cost is minimal compared with the expense of repairing internal engine damage caused by neglected lubrication. Storage conditions introduce another critical factor. Many classic cars spend months parked during winter seasons or extended restoration projects. During these periods, condensation can form inside engines as temperatures fluctuate. Tiny amounts of moisture accumulate within the crankcase, potentially contributing to corrosion and oil contamination. Before placing a vehicle into long-term storage, many experts recommend performing a fresh oil change. Clean oil provides superior protection, while the engine remains inactive. As automotive technology has advanced, some collectors have embraced a valuable diagnostic tool known as oil analysis. This process involves sending a small oil sample to a laboratory for examination. The results can reveal surprisingly detailed information about engine condition. Elevated levels of certain metals may indicate bearing wear, piston wear, or valve train issues long before symptoms become obvious. For owners of rare or valuable classics, oil analysis provides an additional layer of confidence and anticipation by allowing potential problems to be identified early. Oil filters deserve equal attention. Even the finest motor oil cannot perform effectively if contaminants circulate freely through the engine. During the early decades of automotive history, filtration systems were often relatively simple. Modern filter technology has improved dramatically, yet choosing a quality filter remains essential. Experienced restorers frequently emphasize that an inexpensive filter may save a few dollars today, but could compromise protection over thousands of miles. The importance of specialized break-in oils becomes particularly evident after an engine rebuild. Freshly machined components require careful treatment during their initial operating period. Flat tappet camshafts are especially sensitive during break-in because proper wear patterns must be established immediately. Specialized break-in oils often contain elevated levels of anti-wear additives designed specifically for this critical stage. Skipping this step can create irreversible damage within minutes. Unfortunately, many classic car owners unknowingly make common mistakes. Some choose oil solely based on brand recognition without considering engine requirements. Others assume that the newest oil technology must automatically be the best option. Some neglect regular changes because their vehicles accumulate limited mileage. A few overlook warning signs such as declining oil pressure, increased consumption, unusual engine noises, or changes in oil appearance. These symptoms should never be ignored. Low oil pressure may indicate bearing wear or lubrication system issues. Blue exhaust smoke can signal excessive oil consumption. Metallic particles visible during an oil change may suggest internal component wear. Strange ticking or knocking sounds often warrant immediate investigation. Concern today can prevent catastrophe tomorrow. Professional mechanics who specialize in vintage automobiles typically approach oil selection with remarkable care. Rather than relying on assumptions, they evaluate engine design, mileage, climate, operating conditions, and intended vehicle use. Collectors often develop similar habits over years of ownership. Their confidence comes not from guesswork, but from understanding the unique needs of the machines they preserve. Perhaps that is the most fascinating lesson of all. Engine oil rarely receives the admiration directed toward gleaming paint, polished chrome, or powerful V8 engines. It remains largely invisible, quietly performing its task deep within the machinery. Yet few automotive products contribute more directly to the survival of classic vehicles. For the price of a routine oil change, owners gain protection for components that may be difficult, expensive, or even impossible to replace. A properly lubricated engine can continue operating reliably for decades, preserving both mechanical integrity and historical authenticity. In this sense, engine oil becomes far more than a maintenance product. It becomes a tool for conservation. Every classic automobile represents a piece of history. Whether it is a 1930s touring car, a 1950s American cruiser, a 1960s muscle car, a British roadster, a European Grand Tourer, or a Japanese sports coupe, each vehicle tells a story about the era that created it. Preserving those stories requires more than admiration. It requires responsible stewardship. And sometimes, the most important act of preservation begins with something as simple as choosing the right engine oil. Through informed maintenance, patience, and respect for engineering history, today's enthusiasts ensure that future generations will continue hearing these remarkable engines start, idle, accelerate, and inspire wonder for many years to come.